My name is Sichuan Liu. My student ID number is 2012-98393. I'm mainly responsible for the database design for this project.
My name is Chen Zhou, and my contribution and my ID number is 2012-99451, and my contribution to the project is the CSV file.
Hello, my name is Ruizhe Chen, and my student ID is 2012-97748. And I am doing the hardware requirement in this project.
Hiya, my name's Matthew O'Connor. My student number is 201071393. I'm here to sell what these guys did. So, should I start straight away, guys, do you reckon? Good. Right, hi Phil. It's annoying that I can't see you face to face, but this will have to do. So I'm going to start by introducing the group number. We are group 15. The actual group name is Dataholics. We're actually the happiest and smiley bunch. We chose to do the small cinema example. So the database aims to provide basic information about movies, customers, screens and snacks. The proper method applied to access more information on like number of seats for a particular performance as well. So I don't know obviously how this is going to work. You might be looking at the way the report's looking, but I'm going to go straight to the database design. Okay, so it's split into three. So you've got screens, movies, customers. Obviously, it's a bit more hard. I ain't got a presentation board for you, Phil, so I'm going to have to just kind of like freestyle this. You've got screens that points to row seats, which shows you the performance seats, which then splits into either the performance and tickets. You've got movies that helps you with the screen, show what movie is showing. You've got customers that points to tickets, and you've also got snack orders and snack, which all derive from each other. The primary keys being screen ID, movie ID, customer ID, performance ID, ticket ID, and snack ID. Well, that's boxed off. So now we're onto the data dictionary, so scroll down, Phil. So you've got, for the screens, movie, and customers, for the screens we've got ID, class, staff, and the capacity, which makes sense, obviously. We need a number, we need what type of class seat it is. Well, staff and how many people can fit inside the screen. The movie itself has got an ID, a name, and how long the movie will be. And the customer's ID, name, the phone number and email, all the generality things of information. Tickets, ID, customer ID, and performance ID. They obviously are the foreign keys in this one. The type, the made date, and the price of the tickets as well. The movie's showing, so the ID and screen ID again, with a start date and an end date, because obviously you need to know when a movie starts and when it ends. Rows of seats, that's going to be using the screen ID with the row number, with the seat count, so how many people can fit in there, and what type of class that is. So if it's premium seats or normal, and we assume that the premium in each screen is fixed, so keep that in mind. The performance is split into the ID of the performance ID and the movie ID, the performance start and the performance end and the date. The performance seats is the ID of the performance, the screen ID, the row number, the seat count, and the seat status, so whether or not it's free or if it's booked, because that would be awkward. The snack is ID, name, price, and the snack orders is the IDs of the customer and the snack, the quantity of how many of them snacks there are, and the order date on which it took place. So now, Phil, we're going straight onto the task, which these guys managed to divide into three main areas, which is customer, movie, and screens. So the customer, basically ticket and snack order is linked to the customer ID. Snack order and snack is linked to the snack ID to obviously retrieve the price of each and then summate a total. The ticket will link with the customer ID, and it can work out how many number of tickets that specific customer had bought. Let me find the other one here. Yeah, it's here. Found it. Screen, we associate the row seats in screen with the screen ID, and it gives us a detailed layout of the screen, such as number of rows and whether or not a seat is premium or not. The movie associates movie showing with the movie ID to know precisely the scheduling of each movie being shown. For this scenario, we include just the start date and the end date of the movie. And finally, if we want to retrieve all the relevant info for a particular performance, we create a table performance in which we store date, movie, start and end. For more detail, create another table, performance seats, which can give us seat status of a particular performance. So performance seats can be linked with tickets to show how many tickets have been sold and are still available. I hope that made sense to you, Phil, because it does. Right, so the general specifications, you can see that big list. I can't, I haven't got it here. So these guys chose the tower chassis, all connected via the internet. The cinema information, the customer, the ticket information will be stored in this database server. And well, skipping ahead. Wait, go back, Phil. Go back, Phil. So the actual, what you've assigned us to do. So first off, determine how many seats are available for a particular performance. That's performance seats table, and it determines the performance ID and chooses the seat status as available, and the number of rows in this condition will be the number of seats available for that specific performance. That makes sense, Phil. The number of showings for a particular movie, so how many have watched this one. The performance table sets the movie ID as the same number and the row number in such condition, and it'll be the number of showings of a movie. Number of watch can be added, just how many have watched it, you just add that, it's not hard. Determine the start and end time for a movie showing. Well, for that, for a start and end date of a movie, we get the information by determining the movie ID in the movie showings table, and for a performance, we access a specific performance ID. So obviously, as you can see that. Calculate the weekly income. It's split into two parts, snacks and tickets. It'll determine exact date using the order date in the snack orders table and ticket made date in tickets. And the snack can confirm the quantity sold in a week in regard to each snack ID. By multiplying snack price and quantity, we get the income for snacks per week. So that's pretty straightforward. Now back to the specifications, which is that big long list that I was on about. So they've chosen a tower chassis. We're all connected via the internet. All the cinema information, customer ticket will be stored in that database server. And the size, these guys estimated one data document is about 9 KB on average, and the thousands will be produced per day, which is roughly 10 meg per day. The server will operate the system, manage the software, log files, like generate log files and new data. The general size of it, 3T hard drive, and it should last about 5 years on that sort of estimation, but I think we've sold that, and I think the Roxy is actually going to boom, and I think you're going to hire us because we're awesome. That is that. Conclusion. Yes.